Hello everyone, this is Saksham Jain and I welcome you all to the Future Camp. So in this video, we will be discussing our learning path for feed-forward artificial neural networks. So without wasting any time, let's get started. We all know that artificial neural network is the backbone for every other neural network. Whether it is CNN or RNN, artificial neural network play a very crucial role in understanding the concepts of further neural networks. So we will be learning about ANNs in the most comprehensive and easy way, and also we will be implementing each and every topic in TensorFlow as well as PyTorch. So first of all, we will be learning about forward propagation. Once we are familiar with forward propagation, we will learn about activation functions. In activation function, we will first discover what is activation function and why they are used. And after that, we will discuss every type of possible activation function. We will be discussing about sigmoid, tanh, ReLU, leaky ReLU, p-ReLU, leaky ReLU, ELU, GLU, and switch activation and mesh activation. After that, we will be covering about loss functions. So once the features pass through the activation function, we get a predicted output and there is an actual output. So we have to find a loss function. We have to minimize a loss function in order to increase the accuracy of our model. So we will be covering every type of possible loss function. We will be dealing with mean square error, L1 loss, Huber loss, binary cross entropy, softmax, and KL divergence, and constitutive hinge loss, triplet loss, and ranking loss. After that, we will be covering about backpropagation. You won't be able to understand about backpropagation if you don't understand chain rule. So we will first understand what is chain rule so that you will understand the mathematics behind backpropagation. Once backpropagation is complete, we will be dealing with vanishing gradient problems and exploding gradient problems. These two are very important interview questions. After that, we will be studying about optimizers and different type of optimizers. We will be covering about gradient descent, stochastic gradient descent, mini batch gradient descent, Adam, RMS prop. After once these topics are completed, we will be dealing with exponentially weighted average and their bias correction. And after that, we will be covering momentum and SWATs. And once these topics are covered, we will be dealing with weight decay and decoupling weight decay. And after that, we will cover also one extra optimizer, that is AMS grad. So once all the optimizers have been covered, we will be dealing with hyperparameter tuning and learning. Once hyperparameter tuning has been covered, we will learn about weight initialization techniques. We will be seeing that what is normal distribution, HE norm initialization, Xavier initialization, and we will also answer the question that what happens when all the weights are initialized to same value. So once weight initialization techniques will be covered, we will be dealing with regularization techniques. In regularization techniques, we will be covering L1 and L2 regularization. And once L1 and L2 is complete, we will cover normalization techniques, layer normalization, batch normalization, group normalization. And at last, we will cover drop connect. So once all the theory portion will be covered, we will implement our knowledge and try to solve regression and classification problem using artificial neural networks. We will be solving regression and classification using PyTorch as well as TensorFlow. So this is going to be our learning path for artificial neural networks. In the next video, we will be learning about forward propagation. So we'll meet in the next video. Until then, bye bye.